Assalamualaikum and hi. Today I will explain on chapter 4 part 1. Okay. Now we go to learning outcome, explain basic operation digital modulation, explain the concept, explain the different type of pulse modulation. Okay, now why we go digital? Because demand for communication service increase. Okay, but radio frequency spectrum is limited. Power efficiency, bandwidth efficiency, and system complexity are the main criteria for using a modulation technique. Okay. Now, comparison between analog and digital analog. Analog system means you use analog. Okay. Digital system means you convert this one analog, ADC what? Analog to digital converter. DAC digital to analog converter. Means you play with digital. What is the model? Modulator, demodulator. Okay. So this difference between analog and digital. Now, why we go to digital? The advantages, immunity to noise, easy storage, and then easy to regeneration because digital 010101, easy to measure value 010101. Error correction detection you can do easily because if a problem at bit 1 you can detect bit 1, no problem. Okay, but digital modulation also got disadvantage, require bigger bandwidth. Okay, analog signal need to change to digital, not compatible, and then need synchronization. Okay, so this is the block diagram, the basic block diagram. Okay, in block diagram, you will see on the analog source, A to D is analog to digital converter. So this is the function, analog source, analog digital converter, source encoder, channel encoder. You can read by yourself. Okay. Now, modulator, function of modulator, power amplifier, channel, low noise amplifier. Okay, you can read. Okay, and then the modulator, channel decoder, source decoder, DA. What is a DA? Digital to analog converter. Okay. Now, we go to the next slide. Okay, this one summary. You see on the receiver part. This is analog source. Okay, source encoder. Okay, you will deal with PWM, PPM, PAM, pulse code modulation, and delta modulation. How the signal look like? You can see here. Okay, analog signal, we change to the digital. We have pulse width modulation. Okay, the signal look like this. Okay, I will explain this on the next slide. Okay, so how about channel encoder? Channel encoder, you see here. Okay, return 0, non-return 0. How the signal look like? Look like this. Okay, how about digital modulator? You got ASK, amplitude shift keying, frequency shift keying. How the signal look like? Like this. Okay, now we go to this one on the receiver part. Okay. Now, analog to digital conversion. Okay. So the key to digital communication is to convert information from continuous analog into digital form. Okay, at the receiver, digital data must be usually be converted to analog form before used by the user. Okay, this is basic principle of data conversion. We have A to D. A to D what? Analog to the digital. Okay, means we convert analog to digital signal. Okay, how about DA? DA means digital to analog. Now, when you deal with analog to digital specification, you must know this thing: resolution, dynamic range, signal to noise ratio. This is main component. Okay, so the next one, when you deal with ADC specification, you must learn M array encoding. Very easy. Remember this first formula: N equals to log to M. To N equals to M. What is the N? Number of bit. M, number of condition. Okay, now for example like this. Given M equals to 2, M equals to 4. Okay, this example, M equals to 2, find N. Okay, so how to find? M, use the formula. M equals to, right now you want to find N, use this formula. N log 2 M. You put this value 2, and then second example, you put 4 here. So you got answer 1 and 2. Okay, how about the second, this example? The example given you we give you 3-bit system, means n equals to 3. How to solve? How many level? You use this formula, the 2 power of 3, m equals to 8. Okay, now we go to the next slide. Okay, baud and symbol rate. This one is most students got confused, huh? Confused. Okay, now what is the difference between baud and bit per second? Okay, now let's look here this example. Okay, given this signal, okay, in 1 second, okay, this one also same 1 second, but you should know something. Every interval, for example, here only got 0 bit. Second interval also got 0 bit. Here, one interval you got 0, 0. Okay, the second interval you got 1, 1. So here we are using 2 bit. Here we are using 1 bit. So how about bit and bit rate? What is the difference? Okay, baud. How many baud here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. How about bit rate? Bit rate is 10 bps because 10 times 1 bit. Okay, now how about the second one? Second one, baud also same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How about bit rate? Bit rate right now, you must time by 2 because of what? You are using 2 bit. Okay, now let's look on the example. Okay, this is another example. You must remember Fs equals to 1 over Ts. Fs symbol rate, Ts time interval. Okay, okay. The next formula you must know Fb, Fs time n equals to 2bn equals to 2b log 2m. You must know Fb, Fs, b, m, n. Normally in question we give you direct, give you value, direct, insert to the formula, you got the answer. Okay. Okay, now this is example. Okay, right now carry 4 bits. Mean here you got 4 bits. Okay, and then if 1000 signal unit are sent per second, means here sent per second. Okay, so fine. How about the baud rate? Baud rate means 1000. How about bit rate? Okay, bit rate, remember you must multiply, right? So here 1000 times how many bit? 4 bits. So clear? Okay, now we go to the next slide. Okay, you can do this example. Try this example. Okay, now. Okay, this is solution. Okay. Now we go to minimum bandwidth, Nyquist bandwidth. You must know Fs equals to 2b. Okay. Okay. For memory system, you will know that Fb equals to Fs and 2bn 2b log 2m. Okay, this one you play with this formula, you got this formula. Okay. Now bandwidth representation. Okay, I'm telling you what is the important things of bandwidth. Okay, I'm telling you something. This one 500 Hz, this one 4000 Hz. Mean this one bandwidth higher. Okay, why we need bandwidth? You want low bandwidth or high bandwidth? Sure, you want high bandwidth. Why we need bandwidth? Okay, increasing bandwidth improve the presentation of the data signal. See, okay. Then 500 Hz, for example, this one lowest. 500 is too low to reproduce the signal. Want to maximize the capacity of the available bandwidth. Okay, we cannot do the something like the presentation of data not very good. Okay, now ADC specification information capacity. Remember, we got the information capacity. Okay, you cannot send a lot of data. We have maximum. We have something like the capacity to send the data. Okay, remember this formula I equals to B log 2 1 plus S over N. What is S over N? Signal noise to power ratio. Okay, equals to this thing. Okay. Now, let's look on this example. Okay. Given there is an R power of 1000 or 30 dB and signal bandwidth of 2.7 kHz, determine the information capacity. So you insert direct formula. Okay, direct formula. You got the answer. Okay, now we go to the next step. Okay, this slide shows you the analog A to D conversion step. Okay, remember we have process of sampling, okay, and then quantize, and then we code 01001001. Okay, now means streaming that bit means 0101010001. Now This is three process. Now, you should know quantization. Okay, remember why we need to do quantization? Because we want to assign a level. Okay, L equals to number of level. Okay, let's answer it. Find the number of level for following PCM, passcode modulation system. 3 bit. 3 bit. How to solve it? We give you 3 bit. Then use this formula. Okay. 2 power of 3. 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. Okay, how about 8? 2 times power of 8. You got 2, 5, 6. Okay. Now, this is a process that I'm telling you. Okay. Remember, PCM, we got sampling. Sampling. Okay. Sample. What is a sample? We slice the analog signal and then we quantize. Quantize means we assign a level. Okay. A level like this. Okay. We want something like represent. Okay. For example, this signal to vote in analog. How about in digital? Digital in 0, 1, 0. Okay, because we want assign the level. Okay, so remember PCM process sampling, and then after you sampling, you doing level assign quantization, and then encoding 010100001. It's okay. We will have one chapter special too on PCM. Now we go to the next slide. Okay, this is analog to digital conversion sampling process. I mean we slice the analog signal. Okay. Pulse modulation. Okay. Pulse modulation, we got the PAM, pulse amplitude modulation, pulse width modulation, and pulse position modulation. And then we got pulse modulation and delta modulation, analog to digital conversion method. Okay, this is a PAM. Why PAM? It used to describe conversion of analog signal to pulse type signal in which the amplitude of the pulse denote or the information signal. Okay, PWM. Okay, you read by yourself. Here is a pulse duration. Okay, you play with width. The third one, you play with position. Okay, width, big. Okay, thin, position. You play with the position. And then here amplitude. This one more high. This one low high. This is PCM. Okay. I recap back PCM generated by three process sampling. Sampling follow Nyquist theorem. Okay. Quantization and encoding. Okay. So basically, this is the signal what I already explained to you. This one is a small version. This is the big version. Okay, we give you another signal. You sample. That's what I mentioned here. Sample. Okay, and then this one under pulse width modulation, pulse position, pulse amplitude, as what I mentioned before. This one you give into of this one big, this one small. This one you play with the position. Okay, here you play in terms of amplitude. This one high, this one less high. Okay, now we go comparing the pulse modulation methods. Okay, so the pulse signal is a series constant constant width pulses whose amplitude vary according to the analog signal. Okay, so finish this chapter. If you got any problem, let me know in during class. Thank you.